Hello everyone, welcome to lesson 42 of our GoLang course. In this lesson, we are going to explore types and methods as they are both closely related. So let's get started. In Go, user-defined types can be created using the type keyword. This allows you to define custom types that suit your specific needs. You can also derive a new type from existing primitive or composite types. This enables the creation of more meaningful and specific type based on the requirement of the program. The provided example here demonstrates the creation of user-defined type named to-do list. This type is derived from existing type, in this case a slice of string. This new type, that is to-do list, can be used to represent a list of tasks or to-do items. You can add methods to manage the list like deleting and finding elements, which are not available on slices. But since we are deriving a type from slice, we can add those methods. In the previous lessons, struct types have been introduced and created. Struct types are useful for grouping related data under a single name, providing a way to structure and organize information in a program. Again, you use the type keyword followed by the structure name and struct keyword, and then the definition of the structure, or the fields and properties of the student struct. Before we proceed further, let us look at two categories of types. First up, we have abstract types. An abstract type defines what a type should do, but it doesn't provide the detail of how those operations should be implemented. It focuses on the behavior or the functionality that a type should exhibit without specifying the internal details. In the previous lessons, we have introduced function types, which are an example of abstract types. Function types define the signature of a function, specifying the input parameter and return type, but they don't provide the actual implementation. It leaves the details to the implementer of the type. In the future lesson, we will also look at interfaces, which are abstract types as well. Then we have the concrete types. A concrete type, on the other hand, not only defines what a type should do, but also includes the details of how these operations are implemented. It provides a complete and tangible representation of a type, including its data and behavior. A structure with method is an example of concrete type. It not only encapsulates data or the fields, but also includes the methods that define the behavior of the type. The methods provide specific implementation of the action that the type can perform. Let us look at an example. Here, let us first create a type called person. Person is a struct with fields, name, which is a string, age, which is an int. Now let's associate behavior with it. Here, I am defining a method getDetails on the person struct or on the person type. As you can see, the method getDetails returns the details of the person type in a string. So in our example here, the type person is a concrete type that encapsulates the data, which is name and age, and also includes method getDetails that defines how to retrieve details about a person. Now let's get back to our slides to learn more about methods. Methods in Go are functions that are associated with and belong to a specific type. Unlike regular function, which can be standalone, methods are tied to a particular type and operate on instance of that type. Methods can be defined for both custom types, that is, types created by a user, and derived types, that are types derived from existing types like we did earlier with the to-do list. This allows developers to associate behavior directly with types they create, enhancing the modularity and organization of their code. The syntax of defining a method is slightly different from a regular function. In a method definition, the receiver type is specified, indicating on which type the method operates. The receiver becomes an additional parameter for that method. In our example here, we are saying that getDetails is associated with the person type by specifying a receiver, that is, P is of type person, and inside it, we can access it. Let's create another struct with some methods. I'm going to create a struct to define a circle. Here, circle is a type struct with fields radius, which is a float type. Now let's create a method associated with circle type. Here, let us create a receiver, C circle. This is required for creating a method so that the compiler knows which type it's associated with. So I can say the method name is area, which returns a float, and inside it I can just say return 3.14 into c.radius. let's just remove this since we are not using it. As you can see with the receiver, we are able to access the instance of that structure or that type inside the methods. And see, here is the receiver parameter. So that's basically how you define methods on types in Go. Let's learn more about methods in Go. In Go, method overloading, which is the ability to define multiple methods with the same name but different parameter types or numbers, is not supported. Each method in Go must have a unique name, and the method signature, including the receiver type, determines its identity. Methods in Go can be accessed using the dot notation, similar to accessing field on structs. This dot notation allows you to invoke methods on instance of a type. Let's look at another example. So now I'm going to create a type rectangle, which is a struct as well. It will have two fields, length and the width, which are both float 64. Now let us define a method area on rectangle type, r rectangle, which is the receiver, area, which is the method name, and it returns the float. Return r.length into r.width. So that's a simple method area on the rectangle type. Now to access the method on the type, first we need to initialize the type. Here I'm creating a rectangle of length 5 and width 3. Now to call the method, you can just do rect.area, and that is how you access methods on a type. We can do fmt println rect.area. If we run our program, we should see the area printed to the console. As expected, 15 is printed to the console. Methods in Go can have either a pointer receiver or a value receiver. The receiver determines how the method interacts with the instance of type it operates upon. Let's go back to our code to understand it more. What we defined on the rectangle is a value receiver. That is, it's receiving the value. It is useful when you want to access a field on the type. But what if you want to modify the type fields itself in the method? In that case, you will need a pointer receiver. If you pass the value type, a copy will be created and the difference won't be seen on the original type. Instead, we have to use a pointer receiver. So here, I'm going to create a pointer receiver, r, and this time I'm going to accept a pointer and say set length, which will accept L, which is of type float 64, and then inside it, we will use the pointer receiver to update the length of the rectangle with the provided length. In this case, if I call rectangle set length 10, and then let's copy it again and see if the value was correctly updated. Now let's run our program to verify the same. And as seen, the value was correctly updated. Now again, just to show you, if I do this and make it a value receiver, you won't see the changes. And as expected, we don't see the changes. So if your method is set to change the fields or modify the instance of that type, you need to have a pointer receiver. Usually it's idiomatic in Go that you keep the method receivers consistent. So if one of the method has a pointer receiver, then it's suggested to make all the receiver a pointer receiver. So basically, that's how methods are used with types. Let's summarize everything we have learned in this lesson. In Go, developers have the flexibility to create entirely new types using the type keyword or derive new types from existing one. Creating a new type or deriving from existing type allows developers to model their data and functionality in a way that fits their needs. Then we looked at abstract types. An abstract type in Go defines what a type should do in terms of behavior or functionality without specifying the implementation details. It focuses on expected actions or features of a type without dictating how these actions should be achieved. In the previous lessons, we defined function types, which are one of the abstract types. In contrast to abstract types, we have concrete types. Concrete types in Go not only define what a type should do, but also provide the implementation details of how these actions are performed. Concrete types encapsulate both data and behavior, offering a complete representation of a type. Then we saw that in Go, methods are functions associated with a particular type. They operate on an instance of a type and can access or modify the data within those instances depending on the type of receiver you have for the method. After which, we saw how you can either have a value receiver or a pointer receiver for a method. That's it for the lesson. I hope you enjoyed it. If you have any questions, please feel free to post a comment under the video or reach out to the Discord server. I will see you in the next lesson. Happy coding!